For this video demonstration, I'm going to go over a couple of common mistakes people make whenever they're multiplying or whenever they're trying to simplify exponential expressions. An exponential expression is anything that has an exponent, for example, like x plus 1 quantity squared. People are actually pretty good using exponents when it's there's a single term, like, x squared means x times x, or 3 cubed means 3 times 3 times 3 is equal to 27. But people have a little bit of trouble whenever you start squaring or cubing or to the fourth power of polynomials, or something like x plus 1 quantity squared. A lot of times what I notice is students want to square both of the individual parts inside the polynomial. So they'll say like x squared plus 1 squared, and they'll do this. And that's not what x plus 1 quantity squared means. Okay? What does it mean? Let's talk about it for a second. X plus 1 quantity squared, let me rewrite that, is actually saying you want to have two of these multiplied by each other. So you want to say x plus 1 times x plus 1. Now that's going to give you a lot different result than x squared plus 1 squared. Let's FOIL this. Remember what FOIL means? FOIL is how you multiply two binomials. You will get, and we'll just compare the two results, do the first terms, x times x. Do the outside terms, x times 1. Do the inside terms, 1 times x. And then do the two last terms. That's 1 times 1, or 1. Add up my like terms, and I get x squared plus 2x plus 1. Now compare this result to this result, and you'll notice that they're pretty close, except that I've got a middle term here that I don't have up here. This one's correct, this one is not. Again, common mistake. You cannot distribute, I call it distributing the exponent, right? You cannot distribute the exponent when you have an addition or subtraction inside your parentheses, okay? So let me write that down. Do not distribute the outside exponent when you have an addition or subtraction inside your expression. Okay? Again, common mistake. People want to do that. The way to look at it is think of squaring, or if it's a cube, think of cubing the whole expression. Write it out, and then if you need to, you can go ahead and multiply and FOIL or multiply the expression out. Now, you're saying to yourself, but wait a minute, sometimes I know that I can distribute the exponent to what's inside a parentheses. When can you? Okay, well, let's take a look at that. This would be a perfect example. Let's say I had something like x squared y cubed quantity squared. Okay? Then you probably have seen teachers, and you probably have done this, right? And you've done, well, I know that when you raise an exponent to an exponent, you've actually done something you're supposed to multiply. So you go 2 times 2, or y to the 3 times 2, x to the 4th, y to the 6th. Now, why can I do it here and not up here? Actually, you know what? Before I actually do that, let me show you another way. Remember what I said. This square means that you are multiplying two of these. So let me just rewrite the problem. This is just two ways actually to do the same problem. This is what I'm saying by saying that whole quantity is squared. Now when I do this, I am saying basically x squared times x squared is x to the fourth. I get to add those two exponents. Y cubed times y cubed is y to the sixth. And notice I've got the same result. You can either multiply them this way or you can write it out that way and do that. So again, the question is, why can't I distribute here and not up here? Well, because the operation that I have between my terms inside here is being a multiplication or a division, not an addition or subtraction. So the rule is this: do not distribute the outside exponent when you have an addition or subtraction inside your expression. You can, and let me write this out, you can distribute the outside exponent when you have a multiplication or division inside your expression. Okay? So I hope that helps some. It really, I would say this accounts for a huge percentage of the mistakes that people make in all types of algebra. So just remember these two things and you should be in good shape. Now, what's the second common mistake? I wanted to do two of them here if I could before I get rid of this video. The second common mistake, we'll call this common mistake number 2. Is the difference between, oh gosh, let's say negative 2 squared versus negative 2 squared. Okay? You might say, well, there is no difference. Negative 2 squared is equal to 4. And then negative 2 squared is equal to 4. This one's incorrect. Negative 2 squared is not equal to 4. Why? Because really you're not squaring the negative 2, you're just squaring the 2. Here, however, you're squaring the whole quantity. You're saying negative 2 times negative 2, a lot like that first common mistake, right? And a negative times a negative gives you a positive. Down here what you're doing, what I tell my students is pay attention to what the exponent is actually in contact with. The 2 is in contact with just the 2, not the exponent. So really what you're saying here is a negative that's still out there, and then 2 times 2, or a negative 4. So again, if you look up here, the 2 is in contact with the parentheses, so that means you got 2 of them. Down here, the 2 is in contact, and what I mean by contact is there's nothing between the 2 and whatever the number is. So you've got 2 of those. And then again, that is just still sitting out there. So you've got a negative 4. Over here, it's in contact with the parentheses. It means you have 2 of them, and that gives you a positive 4. Okay? So that's a second common mistake that students make. These two common mistakes, if you could stop doing either one of these mistakes, the amount of mistakes that you make, I should say, in your algebra, simplifying your algebraic expressions will go down tremendously. Okay, good luck on that. I hope that made some sense. If not, write me some comments and I can explain it further. Thanks a lot.